Alright, so let's get into example 1 for your true angle problem. So we do the first approach, right? Where you get a true length line at least in one in at least one of the orthographic views. I mean, like you got a true line in a view, yeah? So at that time, how are we gonna solve this? So true angle problems are again based on the intersection between two planes, yeah? Again, two-dimensional planes, 2D planes, yeah? And again, our object is in three-dimensional space. The views are 2Ds, yeah? So our method of solving this type of problem is that we try to get the single point view, yeah? Of the line formed by that two planes, yeah? The two planes that is making that intersection, yeah? Again, you can see it right now. Yeah, it's so wordy. Diagrams are better for your understanding. Therefore, no way out but to draw your diagram. So by doing that, we can be able to get the true angle. Yeah. You know, the angles are between the two lines or two planes, right? So surfaces definitely matters. And we're counting on getting the edge views of these planes for that angle to be to be solved. Yeah. So by doing that, our final goal is to project the true size and shape, yeah, in one of the additional projection or views. So let's take a look at it in example 1. So we have surface A and surface B. Surfaces are identified, see, with the alphabetical symbols right there, A and then B, your right side, your front, okay, view, and then your right side view. So if you look at it that way, you see your surfaces like that, yes? If you look at it from this way, you want to see the edge of it, edge of your edge line of the surface A, and then of course your surface B from the right side. And that's your hardest thing for you, to flip your. So make sure I told you with a little object, right? Keep a little small object, and then make sure you put it to the front, and then flip it to the right, flip it to the left, flip it to the top. So all of our problems here are front, right, and top. So you only have to flip like 2 times, to see how the edges go, surfaces move around, yeah. Okay, then we will of course get into the projectors and the points. So start with our projector point to point, yes. 1, 2 on the same line. So on the right side view is a point. Your 4 is here, your 3 is here, and these are our projectors. They're just a line connecting the corresponding points. We throw our full line, yes, somewhere between the two views. That root doesn't change, always do the same thing, perpendicular, to the projectors your full line is. Then we're going to look for the intersection of the two right planes. So from the front view, we have two surfaces A and B. They are intersecting right here at that line. So that's we identify line 2, 4 is your intersection. All right, we call it the line or intersection because you're dealing with two surfaces. Yeah. If you deal with two lines, it's going to be the point intersection. Right now, you got the entire line in between two surfaces, and they intersect to each other. So therefore, this line is called the line of intersection. And it is line 2, 4, yeah? Then we're going to determine if that line 2, 4 is a true length line, yeah, TL. True length line, again, the rule is it's got to parallel, right, to each other. So that's what we did in previous problems. And you project it from that parallel line. So let's see how we deal with this here for the angles. Look for the parallel. Line 2, 4 is parallel to your full line, yes? Projection 2, 2, 2 2 to 4 projected line is here. Yeah, 2, 4 right there. And that's your true length line. Yeah, so we got our true length line. From there, we gotta go our edge view. Yes, do the same thing. Your projector, your second full line, direction, your measurement directions. Okay, go that way. Your 2, 4 here, your 1 here, your 3 here. Keep, all right, the distances from the full line. Okay, I'm going a little bit faster right now. Yeah, and then connect. So 1, 2, 4, and then 3. See that? What do you see? You see something, right? And that is your true angle. Yeah, because the angle is in between two lines. Yeah, in order for us to measure the angle, you have to have two lines. Yes, and that's your intersecting point. So we're like transferring the data or information, yeah, of two surfaces and a line of intersection into two lines with a point of intersection to get the true angle. Yeah, so now we got it. All right, so recap. So every time we want to solve a true angle problem, your line of intersection, yep, that's the line of intersection is the line in between the two surfaces, yeah, got to be oriented in 3D space. We are in the 3D space as a single point of view, yeah. In the previous example, that's on your front view between surface A and B, your line of intersection is. So with the two intersecting planes displayed simultaneously, I mean at the same time as edge views, yeah, the vertex of their angle, yeah, being the point of view of the line of intersection between the two planes. So that's just bulky in text. All that we want to say is this, okay, and that is the surfaces, and that's a line of intersection, and this is the edge view of the surfaces, and that is the edge view, okay, which is now a point, all right, of this line of intersection, and exists the true angle in between them. Yeah, so that's a recap of that. It will be difficult for you to read it. It has nothing to do with English. Even if you read the English or how perfect you are in English or whatever that is, if you can't be able to get that, what's going on in there geometrically and how to transfer the data or not has everything to do with your intelligence. It has nothing to do with the language, right? Written or talk. Okay, so anyway, so let's stop right here.